Okay. Let's see. Joanne, did I mark you here? I thought maybe you were already here. Huh. Oh well. Okay. So this week, you guys are doing chapter 7, and you have your forum discussion. Your forum discussion this week is kind of a look back at object-oriented programming, um, process abstraction, data abstraction, your attributes, your methods. Is that Christian? I'm sorry? Samuel. Okay. You're looking at methods, constructor objects, and so forth. So just make sure you kind of talk through what you understand in the discussion for this week. And of course, the comments are due by this Wednesday. All right. There's only 2 code assignments this week, minus, not including, the project, which is due on Thursday. The code assignments this week is a baby name combination. Christian? Okay. And a 3-letter acronym. And it's very straightforward. You're going to learn a lot about how to do that today with strings, the character at method, and so forth. All right, let me grab the last 2 folks who just came in. Okay, Samuel and Christian, right? All right, so we're 100%. Okay. There are some tricky things about the character and the string class, and we're going to talk through them, work through some code samples, and that a string is immutable. Immutable means it cannot be mutated. It cannot change. Once it's established, it's that way in memory. It doesn't change. And so there are some weird dynamics with strings because of that, as far as memory location and the way the garbage collector works. We're going to try to address some of those today, and I'll pull up the IntelliJ, our IDE, and we'll do some code samples as well to demonstrate. All right, so we're going to look at the character class methods. We're going to look at string methods, how you declare a string, how you compare it. We'll look at as well the integer class and the double class. These are wrapper classes. We've talked about those before. And we're also going to look at 2 new types of utility classes called string buffer and string builder. These are necessary so that you don't run into problems with memory. Okay. All right, so the string class. When you manipulate characters and groups of characters, it can provide some challenges, especially for the beginning developers. We think that we can do string concatenation all the time, where we have one string literal plus another string literal equals the memory location, our variable. But some interesting things happen when we take a string literal and we append it to a memory location that already exists. And we'll get into that in a minute. So each string that you create, whether a string literal or a class, these are all objects. Okay, and a string variable name is not just simply a simple data type. Strings are more complex data types. Strings are actually made up of character arrays, and we'll get into that a little bit later as well. So we've talked about this before. A variable holds a particular memory location, and we don't teach here at NMC machine language programming. If we did, you would actually get into understanding what machine level memory is and how you address it. Java abstracts that for you. But it's important to know that every time you create a variable, you're assigning it to a particular area in the memory of your RAM. Okay? And there's some consequences to that. I've mentioned this before that two strings, when you compare two strings using the equals equals operator, you're actually comparing memory locations, not the value of those memory locations. And that's important. It's important to distinguish. So, for example, if you opened up IntelliJ right now and you declared string my name, Michael, and then went down and declared string another name, Michael, and then did a method where you said, does my name and another name equal? It'll actually return false because they're comparing memory locations, not the value of the location, the value in the location. So when we're comparing locations, that's how we would do it to determine if they're equivalent. But more often than not, you don't want to compare memory locations. You want to know if Jessa's name is the same as John's name. And we all would know that right away. No, they're different. But when you're programming, you have to use other methods to do that. And we'll talk about that. Okay, here's an example. We have string a name equals Carmen, string another name with a semicolon at the end. Now, I've said this before, when we do not explicitly assign a variable to a string or objects, they carry a default value. What do you all remember what default value they carry? So for their primitives, they carry 0, right? If they're objects, they carry, what's that? I got headset on, I'm sorry. Who said 1? No, not 1, but a string could be, it would be a null. Okay, so all objects, when they're created, if you don't explicitly assign them something, it's a null. Okay, so we have string a name equals Carmen, string another name, and right here when we do this, we're actually creating two different memory locations. Okay, so scanner input equals new scanner system.in. This is old stuff, right? System out print line, enter your name. Another name equals input next line. Now we're assigning a value, a string, to that another name. If a name is equivalent to another name, system out print line, hey, they equal, right? Else they don't equal. All right, so what's going to happen? Based on what I've told you, what's going to be the output? Exactly. Even if I type in exactly capital C, lowercase a, R-E-M-N, it's still going to try to equate memory locations, and that will always equal false. Now, there's a reason for this in Java. The JVM is grabbing memory locations and moving them around all the time. And so typically, the underlying memory locations, the JVM it's handling that for you. So those comparisons would be valid for things like numbers. But when you get into strings, it's a whole different object, a whole different game, literally a whole different object. Okay. So classes to use when working with character data. So we've talked about the primitive type, char. There is an object type or a wrapper class for char as well called character. And you'd spell it out, capital C-H-A-R-A-T-C-T-E-R. And if you want to use it, you would say character, you would, whatever you're going to declare the object name as, equals new character. You can also do what they call auto boxing, where you can say character equals the character that you're going to declare, equals, and then single quotes, a character. By doing that, you've auto boxed and the Java system, the JVM will automatically do that assignment correctly. All right, so the string class for working with fixed string data. String builder and string buffer. These are the two that I want you to get comfortable using when you're going to append strings together. String buffer is, I can't remember here. String buffer, I believe, is for better memory usage. String builder is if you're in a, no, I got it backwards. String builder is for better memory usage. String buffer is for multi-threaded environments. All right, let's go on here. So the character class, it contains a standard set of methods for testing values and characters. All right, I'm going to exit out of this just for a moment. Let's pause the slide. I want to show you this because for the character class and the string class, this needs to be your go-to place every time you're wanting to figure out something about the methods. Okay, let me, we're using 13, right? So we'll change it to version 13. This, really? All right, let's see if it'll go up to 12. They may have changed the URL reference for this. Okay, there is a Java doc for JDK 13 for the character class, as there is one for the string class. This is the one for the string. The Java doc is where you need to go to find the exact specification for everything that the character class contains. You'll notice that it's public final class character. It extends from object and it implements serializable and comparable. Okay, and this information here we haven't got to yet. We may get to that in this class and explain it. Otherwise, I'm not sure if they have a Java 2 here. Do they have a Java 2 here at NMC? Oh. Okay. Everything that you need to know about the character class is going to be contained in the Java doc. And I highly recommend that you take the time to bookmark the Java doc sites, because if you continue to program in Java later on, this is where you need to go. And if someone challenges you on something and says, no, it does this instead, you can say, no, it's right here. Ha! You ever heard that statement? Show me the link. There you go. I always hate that. I'm like, All right. It's all right here. Same thing for the Java doc for string class. And this one, of course, is using 13, which is what you guys are using. Everything is in here. Okay? All right, let me jump back to the PowerPoint for a moment. Okay, let's see here. So there are multiple methods here that you can use. The character class has methods like is uppercase. And so if you pass it a letter, it will tell you whether it's an uppercase letter or not, or if it's lowercase. You can also adjust it and say you can push something to uppercase. So if someone enters a character input and you want to make sure that you're controlling the input always, that you're only validating certain case sensitivities, this is how you would control it. These are the standard methods. So you have is uppercase, it tests if the character is uppercase, to uppercase, is lowercase, to lowercase, is it a digit? This is valuable. If someone types in a number and you want to do multiplication or addition on that number, you'd like to know, is it a number or not something else, right? Is it a letter? Is it white space? Or this will tell you, is it a letter or a number? These are all valuable methods to use when you're using the character class. Okay. This code sample right here, we have a char. This is a primitive. defined as HR equals single quotes, capital C. System out print line, the character is HR. It's using concatenation to concatenate the char to the string, literal. If character is uppercase, so we're using the character class now, is uppercase, HR. So this is going to validate what? Is it true or false? Which one is it going to go into, the top one or the bottom one? It'll go into the top because that looks like a capitalized letter, right? All right, so system out print line, HR is uppercase. If character is lowercase HR, system out print line, it's lowercase. And so again, in this scenario, it's going to go to the false. Okay, so character to lowercase. We're changing the value now to HR, right? Very basic stuff, but it's also very important to have. They're very easy to use utility methods. And I would pay attention to this because your homework assignment is going to use many of these methods that we're demonstrating right now. Okay, so if the character is a letter or a digit, system out print line, is it a letter or a digit? Else, it's neither a letter or a digit. Well, what could it be? It could be a hashtag, it could be a white space, $sign, right? There's a lot of different things it could be. All right. We're not going to get into it in this class, but you can also pass regular expression. I briefly talked about regular expression in the last class we had with you all. You can give a regular expression to the string class or the character class, and you can do some really neat things with regular expression. Okay, so a string literal. What is a string literal? What do you remember about it? Inside the system out print line, it often can take a string literal, right? It's something in double quotes. Okay, so sequence of characters enclosed within double quotation marks, string literal. An unnamed object or an anonymous object of the string class. These also can be string literals. So for example, if you type on the page, quote, my name is Mike, close quote, you have access to the string methods. So you can say dot and use two uppercase or any of the other characters. Those are all valid because you can do those with string literals. String variables, it's a name object of the string class. And then of course the class string. So when we use class string, we're saying string, my class equals new string, right? The string and the wrapper classes are special in that sense that you can wrap them and unwrap them from primitives. It's very unique in that sense because you can't do that with other objects. You can't say to any other object out there, here's a string literal, and pass it and automatically initialize a string. Other objects you always have to create equals new string. So it makes strings very, very special, but also very flexible. Okay, so you declare a string. You can say it like this. String, a greeting equals new string, and you pass in the text, just like that. You can say string, a greeting equals hello, just like what I just described. So what we're seeing here is that you can use the new constructor or you can create it without explicitly calling a constructor. These are very special about the string class. String is a class, it's a variable name, it's a reference, it's a location to a memory location in physical memory, and the address is held by the string is altered. Let's say, I'm not sure what they were trying to say here. Let's go to this example here. This is where it gets ultra confusing. Okay. The creators of this slide, this comes from the textbook, I believe. These numbers actually reference registers in your memory. And so they're saying the address 1080 100876 is where a greeting is stored. And then when you assign it, the address changes to 26040. And then when they concatenate it, it changes again. Now, here is the difficult part, okay? Strings are immutable. So once you create them, that location is in memory cannot be changed. And what is supposed to happen is the garbage collector comes along and says, okay, this thing is out of scope, and it gobbles it up and releases that memory location. However, there are times, if you're not paying attention to what you're doing, you can reserve a memory location and the garbage collector can't get to it. And that's in the scenario that you see here. In this scenario, we have string a greeting equals hello, and then we're assigning bonjour to a greeting. We're creating a scenario where the variable is left in memory. Let me explain it this way. So string line 1, we have string a. This is not going to be in your slides. I created this separately to help explain it. String a equals hello. All right, so this is a memory location created. And I just made up a register number there. Okay. Line 2, a is being assigned to by a plus something else. A is immutable. And now that I go and I assign a string literal to it, I have shifted a, what used to be a, that memory location, off into memory, and now it's not touchable by the JVM. All right. So what we don't want to do is we don't want to do this all too often. When you do this too much, you're going to cause your JVM to run out of memory and you run into problems. When you're doing string concatenation, it's okay typically when you're assigning it to the value, but you don't want to say a plus something else back to the value. That's when you get into an issue. This is where you want to use string buffer or string builder for memory concatenation. Okay? All right. I know this can be a little dry, but this is a very important part of what you guys will be doing. All right. So keep in mind that objects that cannot be changed, such as a string, they're immutable. Think about ways you can make something immutable. What's the typical way I could do it? Exactly. Final whatever. I've made that object immutable, right? Strings, once they're established in memory, they're immutable. All right. Don't fall asleep on me. I know you guys are like, immutable, immutable. All right. So mutatable objects change, right? If you remember back a couple assignments ago, I asked you to create mutator methods. What does a mutator method do? It changes the value, right? Right. So immutable objects that are once established, they cannot be changed in memory. They are there. And that's why we have to allow them to be caught by, picked up by the JVM so the garbage collector can remove them gently. All right. So making simple comparison between strings, this often produces misleading results because its memory locations are different. All right, so think about it. How do we compare strings then? If we really wanted to compare Leo's name against Christian's name, how would we do that? What is the method for that? Equals. Equals is the method that is given to by the object class. All right, I'm going to exit this again. And you're going to notice that string, it extends what? Object. If I go to object, there are some methods in here that are available. I may have told you a lie. Oh, here it is. I was getting worried. It's like, I know this. All right. Equals is a method that is available from the object. So if string is extending from object, it's going to get all of these methods for free. It's a part of it. Okay. It gets equals, finalize, get class, hash code, all of these. So let's go back to string real quick. We'll come down here to equals. Where are you at? See, these are all constructors. There it is. So I click on it. It tells you exactly what this does. It compares a string to the specified object. If the result, if it is true, only if the argument is not null and the string object that represents the same sequence of characters of this object. Okay, so it's going to compare, for example, Leo with uppercase Leo. What would it equal? False. But if Leo was uppercase and it was comparing also to uppercase, it would be true. All right, so let's jump back into our PowerPoint again here and IntelliJ in a minute, because I know it's funner to do that and where you all can type along with me, but this is important. Okay, so equals evaluates the content of the string and determines if they're equivalent. Returns true if the objects have identical contents. Equals ignore case is one of the most loved methods of Java developers in string comparisons, because we're determining, we don't care if it's lowercase or uppercase, but as long as the characters are the same, right? All right, and then again, there's the Java doc I was talking about. Okay, so here's an example in the code. We have string a name equals Carmen, string another name. We're assigning it, as you can see here, and then we're asking the question, if a name equals another name, output it. Now, we won't know this for sure until you actually run the program and do it. And let's just follow along. This is the best way to code and make sure you're getting things, you're learning them properly. This helps with the syntax errors that sometimes I see as well. Some of you, I responded this week to assignments, and there were syntax errors, just basic syntax errors that you'll catch if you're practicing these in class. All right, I'm just going to go ahead and use my, let's just close this here. Create a new project. And I'm not choosing project from template because you don't need to send me the whole zip file, by the way. You only just need to send me just the file, unless there are multiple classes. No worries. No worries. I can hear you. I wasn't going to call you out either. No, you're good. No worries. All right. You cracked me up, Winnie. You didn't have to. All right, here we go. So I've got a IntelliJ project open. I'm just going to create a Java class, and I'm going to call this sample name comparison. Okay. We're going to use my shortcuts again, public static void main tab. I love that when it does that. All right, so string a name equals, what's your all's favorite cartoon character name? SpongeBob. Okay. SpongeBob. Do we want to put SquarePants on this as well, or? All right, SquarePants. Okay, so SpongeBob SquarePants. And let's go ahead and create a scanner class. scanner. You know, we can call this anything, right? The scanner. You could call it Mr. T if you wanted to. It's not a good idea to do that. You always want to call it something more meaningful, but just for demonstrations, it doesn't have to be scanner. All right, so we're going to have Mr. T. We're going to use the delimiter. Oops, there we go. I'm going to use system out print, not print line, because I want the character to be on the same line. Please enter your favorite cartoon character. Okay. Mr. T. Next. Now I forgot to declare the other variable name up top. So we're going to say string, another name, semicolon, right? And down here we're going to assign another name. Whoops, I got next int, didn't I? There we go. Okay, you guys with me so far? Okay, so we're going to say if a name equals another name, system out print line, you have great choice in cartoons. Else, what's wrong with you? All right, that's our sample program. Okay, just add some spaces for readability. Yes. The what I put in the curly braces? No, you don't have to put them in there, but in this scenario, you could just do this. No, you don't have to have the curly braces. However, the curly braces act as code blocks. And I highly recommend curly braces because it's a matter of readability. And it also protects you with if you happen to make a mistake. So, good question. Excuse me. Okay. Are you guys okay if I run the program? Okay. Oops. There we go. Okay, so enter my favorite cartoon character, Scooby-Doo. What's wrong with you? All right, so let's do it again. Let's run it again. And boy, I made it SpongeBob SquarePants. Did y'all see what I accidentally typed? Oh boy. I'll just paste it in, make it easier. You have great choice in cartoons. All right, so that's the equals, right? But the other thing that we demonstrated was the equals ignore case. So in this sample code, if I type in something like this with lowercase p's, currently with it only being equals, because it's taking out of each of the two memory locations, it's taking the strings out and it's saying, are these identical, right? That's how the equals is working. It's going to ask me, what's wrong with you? And I'm like, I don't know what's wrong with you. I told you the answer, right? Because that's the validation. We're trying to figure it out. Okay, so if we want it to be more expressive to handle uppercase and lowercase, then we would say equals ignore case, right? And now if I type in my misspelling, SpongeBob SquarePants, can't believe I did that. All right, now it would tell me that I have great choice in cartoons. All right? Okay, let's jump back to the PowerPoint real quick. We'll demonstrate this as well in a moment. In this scenario, we're saying if a word dot compared to another word is less than 0, let's say if the two strings refer to the same value and there's 0, that means it's correct. If the calling object is less than the object, it's incorrect, or it's more than the object, it's incorrect. Now think about that for a moment. You remember your ASCII charts? Did I show those to you before? I think probably Unicode chart is better. Unicode chart. All right, these are all Unicode scripts, and they comprise all the known character sets in the world. Java uses Unicode, by the way. So each character is a Unicode character. And when they first started creating computers, they were basing it off of the American Systems something units. And so it started at all these characters. And I think it's at number 127. It starts with the letter A and it goes up 26 characters. And then you had some other symbols. And then as other nations in the world began to become more industrialized and they saw the need to bring in other character sets, the international community came up with what's called the Unicode. And Unicode is valuable. Unicode has been in use, I think, since the early 80s. I may be wrong there. But so let's pull up a list of Unicode characters. Okay, so 0 is the null character, 1, and then there's these uses for the characters. You have the bell character, backspace, horizontal tab. You can actually program it with the bell character, and sometimes it'll actually play sounds. It'll do the sound. You have the line feed, vertical tab, and you get all the way down to, well, goodness. Here we go. Yeah. So the Unicode character this at decimal 32, you have the glyphs, and you have your numbers, and then you have your character. So if you were to say, give me the character number at, character is also can also be translated into an int, and you can get the number from it. So here is the letter. All right, so why am I showing you this? When you do compare to, it's actually comparing the physical number related to this Unicode value. And so if the values are less than, then it'll say it's less than. If it's greater than, it'll say it's greater than. That makes sense? So this is actually behind the scenes how equals and equals ignore case works. It's actually comparing the math of the characters. Okay, let's go back here. So we have the compare to method. Let's add this to our example. Instead of a name equals another case, let's just say a name compare to, and we're going to say is less than equals 0. You have great cartoons, choice in cartoons, right? We also need to come down here and say else if copy this, and we'll say is greater than 0. I'm sorry. What's a misspelling? Less than. I'm sorry, less than. All right. Let's make this more meaningful, though. We're going to say a name is less than. And in this case, we'll say a name is greater than. And we're going to change our name up here to something easier for me to type. Bob. Okay. So we're going to run it again. And we're trying to test the scenario of comparing the name. So if I type in Mike, it should be greater than, right? What is our rule there in the code? Let's see. If the calling object is less than the object argument, it's negative. A name compared to. Okay. So we're comparing this value is less than in that scenario. Okay. So this is the compare to. Now, the other ones that we have are, for example, the empty string. Empty strings are, let's take this out for a second. There's an empty string. But here's another interesting scenario. We're going to assign now something to another name, and we're going to attempt to do comparison. But I want you to watch what happens when we do comparison to something that's null. If a name equals another name, system out print line, I can't believe we made it this far. All right. Now, the rules state you cannot, if the string value is null, you cannot use those methods. Think about why that would be. A string exists in memory, right? If we have a memory location with nothing in it, and then we try to attach one of the methods off of that, it's going to throw what's called an NPE. It can't work because you can't run a method off of something that doesn't exist. The memory location is there, but there's nothing there itself, right? All right, so in this scenario, if we look at the code, we have string a name equals null. We're going to use our scanner class. We're going to set another name, and then we're going to do a comparison. And what will happen is a null pointer exception will be thrown. So we'll enter Bob, and there's our null pointer exception, an MPE. It is the bane of every developer. It happens so many times it drives people crazy. There's a lot of debate about whether nulls should have ever been allowed into the Java programming language, but it's there, and so we deal with it. Okay, so you can set strings to null, and strings are null by default. Cannot use the string methods if they're null. It's going to throw the null pointer exception. Okay. So now we have the other string methods like to uppercase and to lowercase. We have length. We have index of, and so forth. And let's go ahead and demo. I'm going to change this back to Bob. And if we run this code, and I type in the right spot, Bob. Okay, so we've compared it. They equal each other. But let's go ahead and take it a step further. Let's take, since we know that next will return a string, we can also utilize the values off of that method, off of the return. So we can say to uppercase, because the value here is string. It's essentially the same thing as doing this, right? So we have the code, we have this isolated as a string value, and we're going to say go ahead and use uppercase to do that, right? So you can do that there. Or you can come over here and say another name to uppercase. Now, when you do this, you have to assign it, because remember, strings are what? Immutable. So you have to say string some other name, right? And now when we do we can compare even if it's uppercase. Well, let's see. We want this guy to be uppercase for our test sequence. So let's walk through the code sample and see what happens. Here, a name is uppercase, another name is not set. We're going to specifically type in Bob in lowercase, and it's going to set it to another name. I forgot to take that out, didn't I? And it's going to validate it. Let's take this out right here because that's going to be confusing to you. And I'm going to do a system out print line so you can see in name. We'll run it again. Okay, we're comparing Bob. Bob is now uppercase. I can't believe we made it this far. All right, so that is using the uppercase. You can also use to lowercase. It does the same thing. You'll notice that both the uppercase and the lowercase have this thing, this variable called a locale. And some places like the character sets, it's important to capture the character set for like some Spanish words. They have the tildes on them. Some French words have special characters. The Dutch, the Norwegian, they have these strange double dots above letters, and sometimes they have words with a plus in the middle. They're different characters. I don't know what they mean, but they're different characters. I'm not a linguist. All right. The other things you can do here is you can actually capture, let's say, you can get the length of a character. So another name length. And that's going to output the length for me. So it automatically gives you the numbers. The other things that you can do with the string class, you can do things like another name, the character at. So say I only want to take so many characters from Christian's name. And I want to validate that when I get these characters that I can do that. So let's say my limit is 5. And I can say int, let's see, char, my char equals, okay, system out print line, my char at character 5 is my char. So we run the code again. Okay, so it's T. Let's count it up. 0, 1, 2, 3, 4, 5. You're like, oh, you messed with me. Christian was just thinking about that a second ago. He's, wait a minute, 9 characters. Something doesn't feel right there. It uses 0 syntax. So remember that a string is a character array, and all character arrays begin at index 0. It gets confusing, okay? So what's some other things we can do with the string class? We can also say another name. We can now say if my char is not null, we could say substring from 0 to the range, which is 5. So if my char, and this is where we want to go back to our Java doc because I can't remember everything. Let's see, where are we at? Char at returns the char value at the specified index. Okay. From a range of 0 to the length -1. The first character. All right, so let's mess around with this first before we do that sequence. Let's I'm going to comment this out for a second. Let's make this number something large. What happens when we put in a number larger than the value? What do you think will happen? So we have Christian. I've put in a 10 up here. So I'm saying give me the character at space 10. You get an index out of bounds. So how would we do this? We would say if the length is 9, then I know I can't make this number 10, right? Yeah, because that doesn't make sense. So what I could do is I could say length and run it. And that protects myself from going beyond the end character. Oh, still a problem. So what was our mistake? Go back to the Java doc. length minus what? Yeah. And what am I doing here? I'm taking the length. Yeah. So if I do -1, I'm actually specifying the character at that length. This is the part where, because things are written as arrays, um, it gets confusing. All right, so my char, and it's not character 5, it's character 9. I should have changed that, right? We could do this by saying what is it? Length -1 plus. I'm going to wrap this. There we go. Because 5 is misleading. Make sense? Okay. So the other thing that we haven't tested here is the substring. So we could say substring of 0 to 5, string, shortened name, and we could put system out print line, shortened named. We're only going to take the first 5 characters. We run it again. Let's pick a different name, someone else to pick on. How about Brandon? Okay, and so what I did is I took the first 5 characters, right? 1, 2, 3, 4, 5. The base start, though, is 0. Now, when you look at substring, this is the part you have to pay attention to the Java doc. Even though we're referencing character arrays, when we say count so many characters forward, we're not saying the array reference, we're saying actual numbers over the array reference. So if the array reference is 0, and I'm going to count 3 characters forward, I'll say 1, 2, 3. And that's how the substring would work, or 5 all the way up. So you have to always go back and read the Java doc. All right. Let's see, what else have we left out here? We did the index of. Did we do that one yet? So shorten name, index of. How about 2? And this is going to output a number. Let's look at the Java doc. This is the other way you can get it if you're IntelliJ. Returns the index within this string of the first occurrence of the specified character. If the character with the value, right? So let's look at our PowerPoint here. Determines whether the specific character occurs within that index. So we're going to mess with Brandon, so we're going to say R, and that's going to give us the index of R. System out I. Okay. We'll do this again. I need to make sure I'm typing the right window. The index of R is 1. So you're looking at the array index, 0, 1. Make sense? I know some of you, it's throwing you for a loop. You're like, Mister, you're talking about the array index starts at 1, but then you're counting using 1, 2, 3, 4, 5. Always remember to go back to the Java doc and read carefully how it's specifying the usage. because it can throw you off. Okay. We did character act, ends with and starts with. It's the same idea as character add. Okay. Replace method replaces all occurrences of some character with a string. So let's take a look at it. Let's say that we have this shortened name, and we want to replace. And we have any number of options here. We have replace with a char sequence. We have replace with characters. We have replace all with strings, and so forth. Okay. Again, make sure that you look at. You know what I'm going to say? The Java doc. Yeah, Java doc is your source of all things. Okay, and then you have this method called the toString. Now, I mentioned this before. Every class that you create is inherently extending from object. So even though over here I didn't say my sample name class, sample name comparison extends from object, by default it automatically does. And so I could literally say this, and that would be the same as me not saying it at all. Okay? When you look at the object class, you have all of these free methods that you get for free, like get class name, get the hash code, the equals method, and you get this other thing. Oh, you get clone. You can actually clone objects with the object class. You get the toString. Okay, so let's take this out to demonstrate. In IntelliJ, you can basically just come right down here and right click on it, go to, where is it at? Is it generate? Yeah. Generate a toString method. And if I click OK, notice what it says. It overrides, because now I'm overriding its parent class, the object class. Okay, I'm overriding the toString method from the object class. And so now when I say sample name comparison, it's going to print out sample name comparison. All right, but let's demonstrate what really happens here. So we have system out print line, and instead I'm going to say super toString, which calls the object class. Hang on. Let's say public void print super. Y'all saw what was happening there? All right. And public void print this. So we're going to say super is referring to object, which gives me toString. And here we're doing this dot toString, which is referring to this. All right, you guys following along with me? Know what I mean for the most part? Okay. So we're going to come up here. I'm going to initialize my class. It is sample comparison SNC equals sample new comparison SNC print super SNC print this. All right, so when we run this, Bob, that's got to be longer, doesn't it? All right, we'll stick with Christian. So the non-overridden version has this hash code at the end. The one that we overrode just has sample name comparison. Okay, toString is available from every single object in existence, except primitives. Primitives, they use a different mechanics under the hood to get you to be able to do string concatenation. But what this means is that a string, for example, if I say shorten name to string, I'm calling the method for the object class, whether it's overridden or not. So let's go into string, and we can see here that what have they done? They're overriding the toString method so that it will return a reference to itself. Otherwise, if they didn't have this in string, what you would get is this funky character set below. This doesn't reference the memory location. It's another hexadecimal reference that the JVM uses for that object. Okay. You guys, I can tell you're getting a little bored with strings. Yeah. All right. So we need to push through this a little bit further. So we have concatenation. We've demonstrated this before using my age is plus my age, right? The string literal plus the variable. We've talked about the substring method a little bit, how you can use it for the start position and the end position. So you can take any string and say, give me the character set from here to there. Okay, that becomes valuable, especially if you're searching for text. Let's skip on through this one. You have region matches, where you can match two variants of a string and see if they're equal. Okay. And then you get into the integer class. All right. Let's go back to our sample over here. I'm going to take out just about all this code. Take out all of this. And we're going to call this a string number. Leave it uninitialized. Use scanner again. Okay, please enter your age. Now, if I say next, I pass this into a string number. I've assigned what we hope is a valid age. So what we're going to do as well is just do sentimount print line. You entered okay. All right, so we're going to enter an age 21. You entered 21. Now, let's say we want to convert this to a number. Now we know that you can use next.int to do that, but sometimes you don't have that. You don't have that ability to convert things to. Maybe the scanner class is not available for some reason, or you're validating input through a web interface or some other way. So the way you would do this is say integer parse int. And we'll pass in our string number. And instead, we're going to use I. Now to validate that I is really what we say it is, we're going to say I times 2. Oops. There we go. So I'm taking the scanner input, I'm converting it, the string, into a number, and then I'm going to do a simple mathematical calculation on it, right? So we run this again. You entered 100, right? That could be a fun way to mess with people's brains, right? You are really this old. All right, so that's using the parse int. The other one, the parse int, is a wrapper class. It wraps around the primitive, okay? And then, of course, we have, there's the value of method. It converts a string to an integer class. There's the int value. And this, the int value will give you, it'll give you the int value, right? So I can say integer, my int equals new integer 24. It's telling me this is deprecated, right? But just for demonstrations. So my int value. And all this is going to do is just give me the primitive value of the wrapper class, right? Double class, same principle, same naming convention, in fact. So you can say parse double, you can say parse value, value of, so forth, on and on and on. All right, so now we get to the important stuff, string builder and string buffer. So I told you earlier that the string builder is more efficient, meaning it's less memory intensive, whereas string buffer is thread safe. And what do I mean by thread safe? How many of you can think of two things at the same time and carry on multiple conversations simultaneously without going crazy? If someone's talking to you and then someone else comes up and starts talking to you, usually you're like, hey, stop it, right? We're not multi-threaded. We're one-threaded people, okay? We can't think in that capacity, not when it concerns our attention. Now, behind the scenes, your brain is doing something with your heart and your lungs, and it's kind of multi-threaded in that sense. But your ability to focus is only single-threaded. You can have multi-threaded operations going on with Java. And multi-threaded means that it's using the differing processors in your CPU, right? You guys, anyone in here build CPUs, build PCs? Okay. Do you ever buy single core processors anymore? No, it's like now they're like 32 core, 64 core. You know, they're massive, right? Massive processing because it's multi-threaded. So one thread equals one process or one processor. And the JVM handles that behind the scenes. All right. That's all for free. String buffer is what you want to use when you're in a multi-threaded environment. Multi-threaded means that you have more than one thing going on with people. Say you are talking to Gabby and to someone else and running maybe some type of shopping cart application. Gabby would not want to order a power drill when she ordered earrings, and Christian wouldn't want a power drill. He wouldn't want the earrings, right? Multi-threaded environments, string buffer protects you in that sense. It keeps track of where the threads belong. Okay. All right. So let's take a look at the string buffer real quick. Topic for the day. So we have our scanner class, and I'm going to leave that at the top. And we're going to just say system out, print line, or print, please enter a character. Okay. And we're going to put this in a do while loop. Do while. And our sentinel value is going to be, let's see, int, or let's make it a string. String sentinel is going to be 999. While sentinel is, sentinel equals ignore case (999). Okay, and I want this to be a not statement, right? Because I want to exit out before I get to that point. So we're going to create a string buffer up here. We'll do a string builder. String builder SB equals new string builder. And we're going to take the scanner and say next value SB append. Okay. System out print line SB to string. The toString method is going to generate the string contents of what you're appending over and over again. All right. How's my code look, guys? Is it okay? Did I miss anything? We don't need this up here, do we? So we got our scanner, we got a sentinel value, we got a string builder, enter a character, and hit enter, right? Because the enter is going to give us that new line up there. Okay. So we're going to run this. And we're going to enter a character and hit enter. C. And it exited. What happened? Okay. Let's change this up for a little bit. Let's say Boolean flag equals true. Flag if y'all bear with me for a second. I want to make sure this is readable for you guys. Scanner, introduce the value, letter, if letter equals ignore case 999, flag is false. Okay. that make sense what I did? All right, we're going to have to make this quick here. All right, so enter a character, C, enter another character, H, enter another character, A, R, A, C, T, E, R, space. Like, oh, you can do spaces? Absolutely. Character typing is okay. I do that, and then now I need to enter a sentinel value, 999. And what did we miss? Oh, snap. I never assigned it, did I? Append letter. Okay. But you see what's happening there, right? All right, so the whole purpose of this was to demonstrate the. All right, so T, H, E, 999. There you go. The 999. Now, why did 999 get appended to it? Because I didn't tell a letter not to get appended, right? It just went in. So you could do this, else, to make sure that your logic is controlling, right? Your flow control logic. So now when we run it, B, O, B, 999. There you go. So we've controlled our flow control. We've used the append using the string builder, and then the system out, the toString on the method. Okay. Any questions so far? Remember, string builder is less memory intensive. String buffer is more memory intensive. You use string buffer in multi-threaded applications. String builder, you won't. If you don't need multi-threaded for a particular operation, then use the less memory intensive version. All right, guys, it is 5 o'clock. Reminder, your projects are due on the 5th. 5th is when? Is that Thursday? Yeah. And I don't remember. Is that Thursday at 11:59 p.m. or is that Thursday at 3:30? You guys look that up. Make sure you have all that done. We'll go over the assignments on Friday. There's just a few more notes to go over for strings. Please take the time to go through and read your chapter text on strings and characters. It's very important. It will help you when you go to do your assignment. If you're not paying attention to it, then it's going to be a real struggle. All right? All right. I will catch you guys Thursday.